Let's talk a little bit about machine learning and data management in H2O Driveless AI with Datatable. So I hope you attended a great talk made by Arno this afternoon, where he mentioned Datatable as a cornerstone for driverless AI. But actually, Datatable is open source and free, so any of you could use it for machine learning or data management purpose. So you see some people already start using machine learning Datatable capabilities for competitions, and they are really impressed by its performance. So you can really process 9 million rows within seconds. And we didn't pay to Oliver to make this advertisement. This is how it really goes. So what is behind this story? We recently implemented FTRL, that stands for Follow the Regularized Leader algo, for binomial classifications in Datatable. And this thing is based on the model proposed by several Google folks. And we did our own implementation of this algo that has a Python front-end and C++ backend. So it's parallelized with OpenMP and Hogwile. This is what makes it so fast. It supports most of the data types, and it is using hashing trick to make learning really efficient. It's based on more hash function, and also supports feature interaction, second-order interaction in this case. We also went a little bit beyond this paper. So this paper covered only binomial classification problems. So we went a little bit beyond it and implemented multinomial classification and also regression for continued targets based on kind of similar approach, but this is still experimental, even though it shows pretty good performance and pretty good results in driverless. So here is a simple example how you might want to use this FTRL model. It's easy as is. You do everything with Datatable. You can read most of the popular data formats with just single line of code. You can define your training data and target column. You create a FTRL model by specifying some parameters. If you don't specify, it will default to some reasonable numbers. So basically, one of the most important parameters here is learning rate that you want to adjust and number of bins for the hashing trick. So no matter how much memory you got on your computer, you can always adjust number of bins to reflect your needs. And then you do fit. You can get access to feature importances when you fit the model, and you can make predictions based on the trained model. So it's easy as is. Some reasons why you want to use it. So it's reliable. So now it's integrated into H2O Driveless AI as of the most recent version. It's fast. It can process 1 million rows in seconds, as you see. Of course, it depends on number of columns. If you get 1 million of columns, it will be slower. But for some reasonable number of columns, it's really fast. It's all Datatable, so there is no dependencies. You just do pip install Datatable. You can do data management. You can do learning. And you can save your results, you can pickle the model, you can do whatever you want to do, and you don't need to worry like transferring data between different formats and moving them between different packages. It's already on Kaggle thanks to Boyan, Kaggle master, who is here. He put it as a kernel on Kaggle. You can go online and start using it right away. And it's open source, so we're not hiding anything. You can go online, you can check implementation, you can contribute, you can change some details, something if you think it's not working properly for your case. And I think the main reason why we have such a successful case with implementing this kind of models in Datatable is the Datatable itself. So Datatable is a brilliant package, written mostly by my colleague Pasha, who will continue this presentation introducing Datatable to you guys.
The next slide is called What is Datatable, and it's designed for people who never heard of it. But those people who work in data science, specifically in R language, of course know that in R there is data.table package, and it's one of the most popular, top 10 most popular R packages, and every data scientist really loves it. And every data scientist that we talked with always kept talking of, I wish I only had this same thing in Python. That's the only thing I miss from R. So when we started working on driverless AI almost 2 years ago, we basically faced the same problem. What are we going to do for our backend? Are we going to use pandas? But we knew that pandas has has problems that will be very difficult to overcome. It is memory hungry, and it does not utilize full cores, and it has a lack of proper NA support. Many of those problems, by the way, are slowly getting resolved in more recent versions of Pandas. I have a 0.24 released just a few days ago. It was a great release and fixed some of those issues. But anyways, we decided that we need a data table port in Python, and everybody who we talked to thought that it was a great idea. So the capabilities of data table that we decided that will distinguish it from other existing packages are that we want to have multi-threaded algorithms for all data munging. Since our primary target was a server, which typically has hundreds of cores, it's rather inefficient to be constrained to a single core Python environment, single-threaded Python environment. So we wanted everything to be multi-threaded. We wanted everything to be very savvy of how much memory we use, because Python is known that it can run out of memory pretty fast, especially if you have big data. So we wanted to have a capability to work with as large amount of data as we can fit on a machine. And as a consequence, we wanted to have ability to have memory-mapped data sets. Memory-mapped data sets means a data set that lives at the same time can live in memory or on disk. This is the same capability that is currently developed in Arrow library. So there was no Arrow back then. So this is something that is really useful in Driveless, because it allows us to quickly save and load data in and out, quickly exchange data between processes, restart different processes, and just allow us to save a lot of time on not unloading and saving data. And of course, for efficiency, we wanted native C++ implementation, and from the very beginning, we thought that this part of Driveless will be open source, just as our data table is. So let's start with the beginning. I'm sorry if the font is a little bit small, but this is a data table package. The first thing that you usually do when you need to deal with data is you load it. And we have this freed function. It's called the same in our data table. A freed basic is a generic function that loads any data source. And in our case, a CSV file, but it can also read Excel files. It can read files within archives. It can read text files that are not CSV. And this also shows an example of how the data looks in Jupyter. For example, one distinction from Pandas, it will always show you a progress bar while it's running. So you know if you have a 100 gigabyte file and you're running it, you'll know how much time is left. That it's not hours. It's just a minute left, or however long it would take. We also show color code the type of each column, so that you can glance at the data and immediately see how much space each column occupies, and what type it is. So that because oftentimes you load the data and you see that it ended up loading as a string, but it looks kind of like a number because you cannot really tell the difference between a number or a string. So you would be able to look at a glance at the column and see what type it is and how much storage is occupied. So if it's 64-bit, but you really wanted to have a 32-bit, you will be able to fix the problem right away. And of course, it handles integer arrays natively, as we always intended. And nice part about it is that freed is really fast. It comes from the same implementation as R, which, as you know, is blazingly fast. It's even slightly faster because it doesn't use R internals as much. We believe that it's fastest among all possible solutions in any language. We have not seen any other solution that can read CSV files faster than freed. And I call it the doorway to driverless because this was the very first thing that we developed for driverless because the first thing that you do, you actually load the data into the driverless AI. And the requirement was that we wanted it to be a smooth experience for users. So we wanted to say, point to the data on disk and load it without errors or without problems. And this is why we automated it as much as possible. There is almost no user intervention needed to select any parse parameters or select any types, or no need to deal with errors most of the time. So next step in driverless is always to save the file, because you just read it from a text format, and text format is unreliable. Much more reliable is a binary format that you can always read back on. So save function we store in the binary format, which we call J. It's really fast, as you can see. It stores at a speed that is actually faster than the disk speed, because we don't wait for it to for the operating system to finish writing, because we can just say write this data to disk and we don't care when, and we can start using the data again, which means that, for example, if you write this data on disk and then we read it immediately, then we don't even need to wait it to be flushed to disk and then read from disk again. It all remains in memory, and therefore it's very fast. And this is an approach that we use when we finish reading the data and then distribute the job across multiple processes, and then within each process we read the same data, and it's all shared memory, and it's as if we use some kind of secret technology to share the data among multiple processes, but it's just saving and writing to a file in a smart way. And as you can see, reading the file is actually in microseconds, because it's a memory map that we just tell the operating systems that you need to pretend that this file is memory and then start reading from it. And therefore, it's super fast to actually start dealing with the data, especially if it's not really flushed to disk in the first place. If it still remains in memory, then the operating system knows and deals with this paging of memory in a smart way. So let's start talking about the actual data table. So for those of you who worked with R data table, you know that it's known for its so-called esoteric syntax, which basically the idea that it's called DTIJ by, which is square bracket notation with these three symbols, and some people love it, some people don't love it because they don't understand it. So it's actually not that hard to understand, and this is the thing that we wanted to bring over from R, because we are among those that actually love that. So the idea is that you address to a frame, and in this case dt is a frame, you address a frame as if it was a matrix. And in mathematics you address a matrix by two indices, a row index and a column index, so it's I and j. But then we say, okay, I and j could be not just an index, it could be many more things. In Python it could be a slice, it could be, but we could expand it. It could be an expression, it could be another frame, it could be many other things. And if we start supporting all of those things, suddenly the syntax becomes so powerful that you can express almost any idea in that symbol, in that syntax, especially if you start combining it with other helper keywords, such as by, which achieves group by. Basically, whenever you have a by in your expression, it means that I and j symbols start to be constrained to each group within the data. The sort, which is means that you also want to order the data in a particular way, and a join, which means that you want to bring another frame join to this and start working it together. And this syntax is actually has a parallel to SQL, and probably most of you know SQL, but in SQL there is also, they say, select j are the columns, from the data table, and the join, there is a where condition, group by, and order. So it's, and this is the primary expression in SQL. And in SQL, almost everything you achieve through exactly the same form. So in data table, we also can achieve almost everything through the square bracket notation. So here are some concrete examples. We loaded in one of the slides before, we have the airlines data set. So they have things like, we have flights information, when different flights started, when they arrived, how much delay, and so on. It's just an example. So here, for example, what if we wanted to find the average flight duration? Well, we use a square bracket notation. First symbol is a colon, means select everything. Second is a mean of difference of two columns. Unlike in R, where you can just use anything anywhere and it's just have a very flexible syntax, in Python it doesn't quite work like that. So we have this F, which means which introduces a namespace that allows you to access column names. So f.rtime means the arrival time on this data set. And dep time is a column called dep time on this data set. So the average of arrival time minus departure time is the average flight duration by flight number. That produces a data set such as in this example on the right. So grouped by the flight number, the average duration. I did not introduce any column name for that. So the second example is built on top of the previous one. Suppose I want to. I looked at this data set. I see, okay, some of them is negative, some of them are NAs. Maybe I don't want them in the data. Maybe I just want to remove them and don't deal with them. So I can say delete me from the data set. The condition, the column is C0. So either the column is negative or the column is NA. Delete me records with all columns. Join with this table. So it means that within the same expression, I say that join me this helper table, find me the rows where the flight duration is either negative or NA, and then delete those rows. So it's all in the same all in a single expression that uses square bracket notation. No need to introduce any temporary variables and so on. So and for the last example, for example, it was recently a question on Stack Overflow. Suppose we wanted to select 3 longest flights for each carrier. How do you do that? Well, you just say that we group by the carrier. We sort by the opposite of the duration of the flight, air time. And then we select the I expression is a column 3, means select the top 3 rows, and that just produces everything. So the combination of these symbols, I, J, by, sort, join, allows you to express a great variety of ideas that would be much more difficult to express if it was just a series of different, much more constrained operators as we've seen in other languages. So I think that's the end, and it's time for questions.
Thanks, Pasha and Oleksiy. All right, any questions? Let's put out the questions on the screen as well. We probably have a couple of questions. Time for questions.
Yeah. I don't know. Okay.
Do you have a question listed or no?
Yeah.
My question is, so would Datatable then be helpful in like coding out second and third order interactions versus where it might be slower and like random?
So of course you can interact variables. You can produce, I don't know, a combination, a sum, a product, or if one of them is binary, or you can factorize them and produce a product of factors, and then you create new columns with them. But in specific applications, such as, for example, FTRL, it might be faster to produce those interactions on the fly, because you produce them, you consume them, and then you discard them, and you never have to materialize them in memory. So it might be a little bit memory more efficient to actually use it within the model itself.
Yeah, so when we do feature interaction, we don't really create a data table with all these features, right? We just do it on the fly. So on the fly, yeah, and you can do arbitrary order actually. I mean, for the moment it's second order, but in principle you can mix together different features. You can just provide explicitly the list of features that you want to interact So you don't really need to create a new data table based on all these features. You just say, okay, I want column 1, column 3, and column 5 to interact, and then and then it will So for the moment, it's not general as is, but there is nothing preventing us, stopping us to implement it, because we actually have a request from Driveless AI when they want to do feature interaction. They want to pass explicitly what features they think are important, and this is what we are going to implement next. So it should not be really complicated.
Pasha, you have a question.
Yeah.
You have time for 2 quick questions.
Okay, so the first question about Redshift. So we do not have any any Redshift connections or any other data sources. So I would recommend you to load them in Pandas, which has those connections, and then convert from Pandas to Datatable. Second question is whether it is fully as featured as our data.table. The answer is no. We're still in the active process of development. We release new version regularly. We just had a new version released today, and we hope to continue that process on.
Thanks, guys. Thanks, Pasha.
Thank
Thanks,
you.
Oleksiy.